Good morning friends. In previous video, we have learned about the Six Sigma. We know that Six Sigma is a set of methodology and tools used to improve the business process by reducing defect, errors and minimizing variations and increase the quality and efficiency. The link is given in description. You can click the link and watch the video. In this video, we will know about the Sigma level. Before we know the Sigma level, we have to learn some terminology. The first term is mean. Mean is a arithmetical average of the process data set. We all knows the mean is also known as average. Mean, the formula of mean is sum of all observations divided by total number of observations. Now you know the central tendency. Central tendency is the tendency of the data to be around the mean. A central tendency is a central or typical value for the probability distributions or populations. For example, mean, median, mode, these are the central tendency. These are the characteristics of data. So let's explain by some example. Here is a example. Here is a data 2, 3, 5 and 9 and 11. These are the data and we have to calculate the central tendency by terms of mean. So we have to sum up all the data. The sum of the data is 30 and number of observation is 5. So the mean value is 6. Mean is a central tendency. Next term is standard deviations. Standard deviations is also called sigma. Standard deviations determines the spread of data around the mean or central tendency. A standard deviation is measure of how dispersed or spread a data in relation to the mean. Low standard deviations mean data are clustered around the mean, and high standard deviations indicate data are more spread out. Here is a two examples shown on your screen. This example is bell-like curve. In first example, first is a narrow one, which indicate data is clustered around the mean. It is an example of low standard deviations because all the data is clustered around the mean. The dispersion of data is very low. That's why that is called low standard deviations. In second diagram, data is more spread out, which indicate high standard deviations. What is our prime objective as a measurement or as a process control? Our main objective is process control or measurement is achieve low standard deviation. Now let's cover the sigma level. Sigma denoted by a symbol sigma, which is a Greek letter. Sigma represents the standard deviation of the population. It represents the dispersion or spread of set of data's value with respect to mean. Sigma quality level is a number that provides a quantitative measure of the capabilities of any process. It is usually indicate the letter Z. Here is some example. You can easily understand with help of this example. In the above figure, the red curve indicate a 2 sigma level of a performance where we observe that peak value is very low and the variation from the extreme left to extreme right is very high. It is a 2 sigma level. It means too much variations. When we applied some tools and methodology of Six Sigma and improve that sigma level 2 to 3, then you can see the green curve. After implementation of Six Sigma tools, we achieve the 3 sigma level. You will observe that the process variation reduced and the process has larger peak as compared to 2 sigma level. When we applied more extensive use of Six Sigma tools and achieved the 6 sigma from 3 sigma level. Please see the blue curve. The process becomes centered between upper and lower specification limit and does not have much variations. It means the Six Sigma is centered between the upper and lower specification limit and does not have much variation in case of Six Sigma. Sigma level is a representation of a process capability in terms of opportunity and defect. It means sigma level can be defined in terms of opportunity and defect. Sigma level refers to number of defect per million opportunity, which is called a DPMO. Higher sigma level means low number of defect. If your process is having 1 sigma level, it means your process having 691,462 defect in per million opportunity. If your sigma level having 4 sigma level, your process having 4 sigma level, it means your process having 6,210 DPMO, defect per million opportunity. And with help of Six Sigma tools and better quality control, if your process is achieved 6 sigma level, it means your process have only having 3.4 defect in per million opportunity. In this table, you will observe that as a sigma level increase, the defect decrease. For a Six Sigma process, the defect is as low as 3.4 in 1 million opportunity. Now we have only listened about Six Sigma. Can we have any process which has 6 sigma level or more? Do you know any process that having sigma level more than 6? Yes. The answer is yes. Pharmaceutical companies, airline manufacturing industries, and many other industries are bound to work at the sigma level, which is either 6 or more than that. If you are not able to perform that 6 sigma level in that industries, the organization cannot be exist, because it's a fundamental requirement for this company to work more sigma level. For example, suppose you are in a flight and fly above the 4,000 feet, the flight suddenly break down. The flight break down due to some technical or manufacturing defect. It can be disastrous accident, and to avoid such disastrous conditions, higher sigma level is necessary. What sigma level? It is always asked. What sigma level we should maintain in our process control to satisfy our customer? This is a common question asked by process controller or quality controller. The answer is majority of companies, most of the companies, a goal set is to achieve the Six Sigma. But don't expect to achieve it with the cost of your organization. It is more important to understand how much your customer willing to pay for the quality, and that our desired sigma level can be met at that cost. Comply customer specification and maintain the control process is much more important. But many industries, it is necessary to go high sigma level, such as pharmaceutical industries, airline manufacturing industries, because they supply products or service to the society. Next session we are going to learn how to calculate sigma level and DPMO. I hope you like the video. Thanks for watching.